Right, folks. Think I'm doing the last one. There is a story. A string is attached to a block of mass 4 kilograms, which rests in limiting equilibrium on a rough horizontal table. So this is a rough horizontal table. The table is not inclined. So the string makes an angle of 24 degrees above the horizontal, and the tension in the string is 30 newtons. Draw a diagram showing all the forces acting on the block. Right. So let's assume this is our surface and there is the object. Um, we are told the string is making an angle of 24 degrees to the to the horizontal, and the tension in the string we are told is 30 newtons. Uh, which other information do we have? We are told that this plane is rough, so if this object is likely to move forward, we expect to also have frictional force. And remember, we agreed from the last presentation that the object experiences a force perpendicular to the surface, which we call the normal reaction force, which we will use to calculate friction. And every object has got a force which is attracting it towards the center of the earth, which we refer to as weight. So I can say here, W. Now, what are we asked to find this time around? We know that this object's mass is 4 kilograms. So the moment we have 4 kilograms, it means we can find the weight. And let's see. They want us to find the coefficient of friction. So coefficient of friction F is equal to mu R. So in order for us to find coefficient of friction, what it means is we need to get the value of F, friction. Sorry, we can find F and also find R. How best do we do that? This object, we are told, is in limiting equilibrium. So if it's resting in limiting equilibrium, we are not sure which direction it will take. So there are two possibilities that if it happens that the frictional force is more than the force applied in the string, then it means the object will move to the left. Oh, let's check how the equations work. The object is not bouncing, so what it means, weight and normal contact force are equal. But remember, this string is acting at an angle, so we will have the horizontal component, which is 30 cos 24, and we also have the perpendicular, which is 30 sine 24 degrees. Let's try and digest this. Um, we are saying F is going to be equal to 30 cos 24 degrees. But remember, F is calculated as mu R. And what's our R? Now, if we want to look at R we are finding it in the perpendicular line. So we are going to say somewhere here, there are two forces acting upwards, R and 30 sine 24 degrees. This should be equal to the weight because the object is not bouncing. Remember, the mass of the object is 4. So to get weight, it's going to be mg, which is 4 times 10. Hence, we can say the weight is actually 40 newtons. Now, I need R here in order for me to get the coefficient. So I'll make R the subject. So R is equal to 40 minus, when I transpose this to the other side, 30 sine 24 degrees. That's my R. So if I come this side, where I formulated the first equation, I'm going to say mu R, which is equal to 30 cos 24 degrees. If I divide both sides by R, it means I'll have my mu, which is 30 cos 24 degrees all over 40, which is my R here, 40 minus 30 sine 24 degrees. Let me take my calculator and try and do the calculation. I'll pull my calculator beside so that at least there is space to see. On my numerator, I have, let me reset my calculator at 30. Let me raise it a bit so that I access 0. 30 cos 24 divided by, there are two things there. I've got 40 minus 30 sine 24. Then I close my bracket, equal to. And we need to be careful here, guys. Our answer cannot be more than 1 or less than 0. So there we have got 0.9859. Well, to two decimal places, it may give me 0.99. So let's see. If I pick my mouse and we check what happens, we are saying our mu is 0.99. That's a coefficient. Thank you for watching, guys. Bye.